When we talk about making AI safe, we're not just talking about lines of code. We're really talking about a clash of philosophies. And right now, there are two major schools of thought. On one side, you have the architect, trying to design a perfect, flawless system from the top down. And on the other, you have the explorer, who ventures into the messy, powerful frontier of what these models can do and tries to improve them along the way. And you've got to understand the stakes are unbelievably high. This quote, it just nails the core problem. As AIs make more and more decisions on their own, we're left with this huge multi-trillion-dollar question mark. When an autonomous AI makes a mistake, who's responsible? Who pays? This isn't some far-off sci-fi problem. It's a crisis we're facing today. So let's really dig into that. It's called the black box problem for a reason. An AI gives you an answer, but the why behind it can be so ridiculously complex, it's almost impossible to trace back. And this creates a massive gap, right where accountability is supposed to be. I mean, just think about it. A self-driving car gets into an accident. Is it the car's fault? The developer who coded the navigation system? The company that trained the model on 1 billion miles of road data? Or you, the owner of the car? You see the problem? Without a clear, auditable trail, figuring out who's to blame is a total nightmare. And this liability gap is a huge roadblock for AI in critical fields like medicine and finance. So this brings us to our first philosophy, the architect. The architect looks at all this chaos and says, forget managing the mess, we need a perfect blueprint. The goal here isn't to just patch up an imperfect system. No, it's to design a system from the ground up that's so logical, so consistent, that the question of liability never even comes up. And their solution? It's called the Integrity Engine. What's so wild about this is the sheer ambition. The Integrity Engine is basically designed to be the ultimate liability shield for AI. It uses things like quantum security and a dual ledger system to make every single AI decision totally transparent and traceable. The idea is to turn the AI from a risky black box into a clear, auditable, even insurable asset. And here's the core of how they plan to do it. The system splits the AI's process into two distinct parts, its will and its deed. The will is basically a snapshot of the AI's internal state. What it's thinking, what it's about to do, that gets recorded on one ledger. The deed is the action it actually takes in the real world, and that gets recorded on a second ledger. Then the system cryptographically links the two, creating this unbreakable chain from intention to action. So let's look at the nuts and bolts. You've got 3 technical pillars making this whole thing work. The first pillar records the will, the AI's internal state. The second records the deed, the action it takes. But the real magic, the secret sauce, is that third pillar, the coherence anchor. Think of it like a strict referee. Before any action is finalized, this referee has to check and prove that the deed was a perfectly logical result of the will. If they don't match up, the action is blocked. It's that simple. The big picture goal here is, well, it's kind of breathtaking. It's not just about stopping errors, it's about creating a system with such perfect internal logic that it achieves what the source paper calls a nullification of discordant frequencies. In plain English, that means completely eliminating any internal contradictions. The goal is to create a perfectly harmonious, perfectly predictable artificial mind. Okay, now let's do a complete 180 and meet the explorer. This philosophy could not be more different. Instead of trying to design a perfect system in a lab, the explorer goes out into the wild. They're charting the vast, untamed territory of these massive new models, like Google's Gemini 1.5. Their approach is totally bottoms up. Let's see what these things are capable of, and then figure out how to manage the risk. And believe me, the territory they're exploring is absolutely enormous. Gemini 1.5 Pro can handle a context window of up to 10 million tokens. A token is roughly a word, sometimes even less. So 10 million of those, I mean, that is just a mind-boggling amount of information for a model to hold in its head all at once. It unlocks capabilities we've just never seen before. To try and wrap your head around that number, think about the novel Les Miserables. It's huge, right? While processing 10 million tokens is like feeding the AI that entire novel almost 14 times over, and having it remember every single character, every plot twist, and every little detail from all of those readings simultaneously. This massive context window lets you run some pretty wild experiments. Like, what if you took a language that's barely on the internet, one spoken by only a few hundred people, and you gave the AI all the materials a human linguist would use, a grammar book, a dictionary, all of it? Could the AI just Learn the language from scratch? So, how did it go? Well, researchers did exactly that with a language called Kalamong, and the results are pretty stunning. With all the learning materials, Gemini 1.5 scored a 4.0 on translation quality. Now, a human who learned from the exact same documents scored a 5.52. So the AI isn't quite at human level yet, but think about what this means. It got remarkably close just by reading the books. That's the kind of raw, emergent power the Explorer is working with.
Okay, so here we are. We've got two completely different paths to safety. The architect, who wants to design a perfect system with guarantees built right in from the start, and the explorer, who wants to manage a powerful, evolving system by constantly testing it, learning from it, and improving it. It's really design versus management.
And this really gets to the heart of the difference. The architect's method is proactive. It's about using pure logic to design a system where certain errors are theoretically impossible. The explorer's method, on the other hand, is empirical. It accepts that flaws are inevitable and focuses on a cycle of discovery and risk management. One is chasing perfection, the other is committed to constant improvement. And just to give you a taste of how deep the architect's thinking goes, look at this concept, the paradoxical aegis. It's a proposed defense mechanism that doesn't just block an attack. Instead, it absorbs the attack's own logic and forces it into a self-contradiction, basically making the attack argue itself out of existence. It's like a logical judo move, a shield made not of code, but of pure reason.
The Explorer's toolkit is way more hands-on, much more practical. They're using proven techniques like supervised fine-tuning and reinforcement learning from human feedback, or RLHF, to nudge the model towards human values. And they are constantly stress testing it, running what they call jailbreak robustness tests to actively find new vulnerabilities so they can patch them.
The Explorer's whole philosophy reminds me of the Japanese business concept of Kaizen, which is all about continuous improvement. It was made famous by Toyota. On their assembly lines, any worker, at any level, can stop the entire production line if they spot a single problem. The goal isn't just to fix that one car, it's to find the root cause and improve the whole process so it never happens again. And here is a perfect, real-world example of that Kaizen idea in action. The Gemini team, our explorers, spotted an abnormality. They noticed that if their model was accidentally trained on even one copy of the test questions, its score jumped from a respectable 74% to a suspiciously high 89%. So they stopped the line. They identified the problem as data contamination and fixed the process by creating a truly secret set of test data. It's all about constant vigilance. So where does all this leave us? On one hand, we have the architect, holding up a perfect blueprint for a logically sound, completely auditable AI. And on the other, we have the explorer, constantly mapping a wild, ever-changing frontier, improving the system one discovery at a time. And that's really the fundamental question we're left with. Is the future of AI safety going to be a perfect, unchanging blueprint, something designed to be flawless from day one? Or is it going to be a living system, one that we have to constantly guide, manage, and evolve with? The answer, whatever it is probably going to shape the future of intelligence itself.